Hello, differential equation students, and welcome back to Unit 5. And this is section 6.3, and this is video number 3 and part B, like the second part. And last time I ended the video 3, part A, right here where we have this equation. We got down to here, we were solving this about x equals 0. And I got to this part, and what I had told you was that over here on the far right side, I have like 0 x to the r minus 1 and 0 x to the r and 0 to the x to the k plus r. So that means that each one of these sections needed to be put equal to 0. Okay. And I said I was going to give you basically the time it took you to do the next video. So now what we're going to do is we're going to set them all equal to the 0. And I'll just start over here with this guy, which is 3c sub 0 r minus 1 plus 7 c sub 0 r equals 0. And I want to work this out, right? And what I'm seeing is that they both have this c sub 0 and an r. So if I take that out, I have a 3 times the quantity r minus 1 plus 7. Technically this is a bracket, equals 0. And then we go through this. Well, clearly then I have r equals 0. And this other one, well, this is a 3r. Minus 3 plus 7 is plus 4. So r would be equal to this negative 4 thirds. Okay. Now the thing is, we have the other side here, which would be this 3r c sub 1 times r plus 1 plus 7 times c sub 1 r plus 1 equals 0, and that's for this guy right here, right? Big thing here is we actually really don't care. We don't have to do this one as well, and this is the fundamental difference because we have this c sub 0 here and the c sub 1, and they work kind of in conjecture with each other according to their r's. So because we already have these r's, then this is just going to be some kind of nonlinear piece with them. So we don't actually have to worry about this. Like, we could solve it through, and if I solve it through, I think I get a negative 1 for r or negative 7 thirds. And this is where you can kind of solve both of them and look to see which r values you think are easier. And when I look at this, I think the one with the 0 here is going to make life pretty easy. So I'm going to get rid of that one. And now from here, I'm going to break it down into the two sections, right? So before I do that, it's probably worth my time to go after this piece here, which if I go after that piece, I would have 3k plus 1, I'm sorry, c sub k plus 1 equals, well, this would be a negative 2c sub k minus 1 divided by, now on the bottom here, I'd have a 3k plus 3r plus 7 times a k plus r plus 1. And unfortunately, I don't see anything canceling there, so I'm just going to have to go with that. Now I go into our little splits that we've done before. So I say things like, if r equals 0, then I have, well, if r is 0, that's c sub k plus 1 equals this negative 2 c sub k minus 1. On the bottom, I would have a 3k plus 7 times a k plus 1. And now I just have to think about where k starts. K starts up here at this 1. So then I have k equals 1. Then, and we've done a bunch of these now, so this is c sub 2 equals a negative 2 c sub, okay, so this is 1 minus 1, that's 0, all over, well, this is a 1, so that's 3, that's a 10, this would be a 4 or a 2. 2 times 10 would be this 20. Of course, we simplify as negative 1/10 c naught. Then I do k equal to 2. Then we would have c sub 3 equals a negative 2 c sub 1 divided by, well, the 2 in here now. This would be 6, that's 13, times 3 is 39, which would be equal to negative 2 39ths c sub 1. Then I have k is equal to 3. Then we would have, well, that's c sub 4 equals a negative 2 c sub 2 divided by, now it's 9 plus 7, which is 16, times the 4, which would make a 64 down here, which is equal to negative 1/32 times, well, c sub 2 we know is negative 1/10 c naught, which is a positive 1/320th c naught. And just for kind of symmetry here, let's go one more, and that's c sub 5 be equal to negative c sub 2 over, well, the k in here, now that's 12 plus 7 is 19, times the 5 there would give me a 95 down here, which is negative 2/95 times, well, c sub 2, I'm sorry, this is not a c sub 2, this is c sub 3, which we know to be negative 2/39, and that'll give me a positive 4 3,705 c sub, I'm sorry, this was supposed to have a c sub 1 on it, c sub 1, right? And then the pattern would continue. So when I'm looking at this, right, this would be y sub 1 of x would be equal to, well, this one is my, and here we'd have this, I have this c naught, right? The problem here is that I have c naughts and c sub 1s. So rather than getting away with just a general one like I did on the previous example, now I'm going to have to get into x to the 0, right? Because my r was 0 here. And then it's times, well, then it's c sub 0 times, well, whatever the c sub 0 ones are. Of course, my very first one, right, is just the 1. And then my next one is, because this is a 2, this one's x squared. Then x to the 4th. So then I'd have a minus 1/10 x squared plus 1/320th x to the 4th, and then plus so on. Then it's plus c sub 1 times, well, now what's the c sub 1? Well, it starts off with not a 1 because it's a 1 here, but it's an x. Then I would have x to the 3rd here, so that's a minus 2/39 x to the 3rd. Then it was plus 4 3,705, that's x to the 4th, plus so on. Then we close this out. And that's just for r equals 0. Now I need to go through and I need to do the exact same thing, but this time for r equals this 4/3. okay? And here, okay, we're on 10 minutes for this video. I think we'll be okay. I'm gonna start it anyway, and if I need to stop the video because it gets too long and make another one, I will. If r equals -4/3 now, then, right, now this is where it gets a little bit tricky because I have to now plug it in up here, right? So I'd have a negative, or a c k plus 1 equals a -2 c k minus 1, all divided by, well, 4/3. Remember, -4/3 is going in right here and right here. So if I did that, that'd be a 3k minus 4 plus 7 would be plus 3 times, well, here this would be a -4/3 plus 1 would be a -1/3. So this is k minus 1/3, right? And then like a sneaky trick here would be to factor out the 3 from here, but then at the same time push it into the other one, which would then make it 3k minus 1. And that's just a small trick, just so you don't have to deal with the fractions. And no, it doesn't work out that way perfectly every time, but in this case it kind of does here. Then I just restart, k equals 1, then, and so on. And I think now would be a great time to pause the video. In fact, I'm going to really encourage you to pause the video, because I'm going to pause my video. I'm going to do this through k equals 4, and then the next time that I get back and I'm talking, you'll see all the answers. So pause the video, please. And then now I'm back. So you can see that I've worked out my case. Believe you know that there's sound there. Did them kind of quick. But that shouldn't be too bad. Then this helps me create my y sub 2 of x, which is equal to x to the -4/3, because that was my r value, times my c naught in this case. And then it's this 1 negative, oh, I'm sorry, this would start out at 0, which is really just that 1 then. Then my next one would be x squared here. So then I have a -1/2 x squared. And I got my x to the 4th over here. So then this is plus 1/32 x to the 4th, plus so on, plus c sub 1 times, okay, the first one that I have in here, well, this one's x to the 3rd. So the first one is just x. Then I have -2/15 x to the 3rd. Then it's plus 4 8/25 x to the 5th, plus so on, and we close it. And to actually write these out together now, I would need to combine these two equations into one big one, okay, one giant one, which it shouldn't be overly difficult here. It's kind of difficult for me just because I don't have a ton of space here. Maybe I'll do this so I can actually see my work. Okay. So if I'm going to try to write these out as one giant solution here, now I would have y of x equal to, and remember that these technically have a coefficient sitting out here. What ends up happening is we think about each one of these c's. They are different fundamentally, and we usually just put a variable out here. And we don't need to try to get into all the semantics of, well, what goes here and how do these constants interact, and trying to solve for them if we had initial conditions and things like that. So although it's very sloppy, we're going to get away with, this is a d naught times this c. Well, the problem is if I write it like that, you guys are going to end up thinking that those are the same. So instead of doing it that way, I will write this d naught here times 1 minus 1/10 x squared plus 1 320th x to the 4th plus so on. Then I have plus this d sub 1, and then that's times x minus 2/39 x to the 3rd plus 4 3,705 x to the 4th plus dot 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 plus. Then we come down here, and then we have our x to the negative 4/3 times d sub 2, 1 minus 1/2 x squared plus 1/32 x to the 4th plus dot dot dot, right, so on, plus my d sub 3 x minus 2/15 x to the 3rd plus 4 825 x to the 5th plus so on. That closes this one out, and this is one giant solution in here. And yeah, if we go with what we I've talked about in the past, you should be very, very, very wary of having 4 arbitrary constants. But because this is our first kind of run through of power series and differential equations, we're not going to worry about them too much. We're going to let those lie. And when you take your second course in differential equations, we'll let them kind of iron those ones out for you. And this completes 6.3. The only thing we got left now is our Fourier videos.